Good afternoon, guys. I'm sorry I was not able to take this lecture for the last 2-3 days, but I've decided to take it today and start it with this. It's chemical bonding and molecular structure, a very important topic as far as basic chemistry is concerned. Until unless you don't understand how bonding happens and what is molecular structure of various elements, you would not be able to understand both organic and inorganic chemistry. Even as far as point of view of JEE or NEET is concerned, this topic is very important. So if you have any questions, please ask them to me so we can get those clarified and get those sorted. To begin with, I have already created a sheet with important points and I've already sent it to you. Rather than going through the textbook, which was more time consuming, I think this is a better way to go through it. The first thing that we are going to study about is chemical bond. The force that holds different atoms in a molecule is called chemical bond. So basically, what's a chemical bond? It's the force that hold different atoms in a molecule together. So you all know that the atom is the smallest part of an element that we are, smallest singular part of an element that we are aware of. More than one atom come together to form a molecule. So how come they come together? They come together because of a particular force that's called chemical bond. There is something called octet rule. We already know that an element is supposed to be stable when it has 8 electrons uh, in its outermost orbit, and the valency of these electrons determine how stable a particular element is. So it has to be either 2, which is in the case of an hydrogen molecule, or it has to be an 8, which is in the case of noble gases already. But in other elements, they combine with either with each other or with another element to form a stable molecule. So these electrons that are in the outermost shell, they are called valence electrons. Um, there are some facts that have been stated by Cossell in relation to chemical bonding. Let's go through these steps, through these facts one by one. In the periodic table, the highly electronegative halogens and the highly electropositive alkali metals are separated by noble gases. So in the periodic table, you have electronegative halogens, which are electronegative, and you have electropositive alkali metals. They are separated by noble gases. Formation of an anion and cation formation of an anion and cation by the halogens and alkali metals are formed by gain of electrons and loss of electrons respectively. So if you gain an electron, you become an anion. If you lose an electron, you become a cation. Anion is negative, cation is positive. Both the negative and positive ions acquire the noble gas configuration. What is a noble gas configuration? That they will either have 2 or 8 or 18 electrons in their outermost shell. The negative and positive ions are stabilized by electrostatic attraction. Example, for sodium, you have, sodium would gain an electron, and chlorine would also gain an electron. So then you get sodium and chlorine, which is wherein sodium has electropositive and chlorine is electronegative, and they come together and they form chemically stable sodium chloride, or as we know it as common salt. Modes of chemical combination. By the transfer of electrons, the chemical bond which formed by the complete transfer of one or more electrons from one atom to another is termed as electrovalent bond or ionic bond. So how is the chemical combination done? The first type of chemical combination is transfer of electrons. So there is a complete transfer of one or more electrons from one atom to another, and that is called electrovalent bond or ionic bond. By sharing of electrons, the bond which is formed by the equal sharing of electrons between one or two atoms is called covalent bond. In these bonds, electrons are contributed by both. So in the first case, what happened is one atom is transferring one or more electrons to the other atom. And so that atom is losing the electrons and the other atom is gaining. Both of them are doing this so they can gain their perfect combination. The second way is that they are sharing electrons. By sharing electrons, they are contributing a number of electrons by both, and then together they come to the magic figure. The third is coordinate bond. When the electrons are contributed by one atom and shared by both, the bond is formed and it is known as dative bond or coordinate bond. So only one atom is contributing and it is being shared by both of them. Then that is called as a coordinate bond. Let's go through these one by one. The first one is ionic or electrovalent bond. Ionic or electrovalent bond is formed by the complete transfer of electrons from one atom to another. Generally, it is formed between metals and non-metals. We can say that it is the electrostatic force of attraction which holds the oppositely charged ions together. So what it means, it is done by complete transfer of electrons from one atom to another, that we already discussed. It is usually done between metals and non-metals, and it is done because of electrostatic force of attraction that keeps them together. So one would be a metal and one would be a non-metal. The very good example is sodium chloride. So sodium is a metal, chlorine is not. And sodium's atomic, this is 281. So it has one electron in the outermost shell. Chlorine has 7 electrons in the outermost shell. So sodium transfers its 1 electron to chlorine and gives it 8 in the outermost, and for itself it also has 8 in the outermost shell. So it becomes a stable element with an octet in the outermost shell. And by doing this, sodium gets the configuration of neon and chlorine gets the configuration of argon. Now there is another example, magnesium oxide, magnesium and oxygen. Magnesium again is a metal, oxygen is a non-metal, and magnesium loses 2 electrons, and by losing these 2 electrons, both of them become stable. Okay. Now let's see what are the factors that are affecting the formation of ionic bond. Ionization enthalpy. As we know, the ionization enthalpy of any element is the amount of energy required to remove an electron from outermost shell of an isolated gaseous atom to convert it into cation. Hence, lesser the ionization enthalpy, easier will be the formation of a cation and have greater chance to form an ionic bond. Due to this reason, alkali metals have more tendency to form an ionic bond. For example, in formation of sodium ion, the ionization enthalpy is 496 kilojoules per mole, while in case of magnesium it is 743 kilojoules per mole. That's why the formation of positive ion for sodium is easier than that of magnesium. Therefore, we can conclude that lower the ionization enthalpy, greater the chances of ionic bond formation. So what is ionization enthalpy? Ionization enthalpy is the element, it's an amount, it's a unit of any element that wants to calculate the amount of energy that is required to remove an electron from the outermost shell. So the lesser the I would be there would be a greater chance for an ionic bond to be created. So sodium has a very low IE of 496 kilojoules per mole, wherein magnesium has a high IE of 743 kilojoules per mole. IE stands for ionization enthalpy. And that is why formation of positive ion for sodium is easier than that of magnesium. Now the next one is electron gain enthalpy, electron affinities. It is defined as the energy released when an isolated gaseous atom takes up an electron to form anion. Greater the negative electron gain enthalpy, easier will be the formation of anion. Consequently, the probability of formation of ionic bond increases. So the energy that is released when an isolated gaseous atom takes up an electron to form anion, and the greater the negative electron gain enthalpy, easier will be the formation for an anion. So for the case of chlorine that gains an electron, you can see that it easily forms into a stable wherein it is mimicking a stable element. Okay. So halogen, they possess high electron affinity, and that is why anions are very common in halogens. Lattice energy or enthalpy. It is defined as the amount of energy required to separate 1 mole of ionic compound into separate oppositely charged ions. Lattice energy of an ionic compound depends upon following factors. Size of the ions, smaller the size, greater will be the lattice energy. Charge of the ions, greater the magnitude of charge, greater the inter-ionic attraction, and hence higher the lattice energy. Okay. Now let's come to general characteristic of some ionic compounds. Now there is a physical state. They generally exist as crystalline solids known as crystal lattice. Ionic compounds do not exist as single molecules like other gaseous molecules. Example, hydrogen, nitrogen, oxygen, chlorine. So physical state is mostly like crystalline solids. They are not like single molecules like other gaseous molecules. Melting and boiling point. Some ionic compounds contain high interionic force between them. They generally have high melting and boiling points. So the ionic compound, certainly we have already studied in the past, they have a high melting and a high boiling point. Solubility. They are soluble in polar solvents such as water, but do not dissolve in organic solvents like uh, benzene and I think that's carbon chloride. Yeah, so they are easy. They are not. They don't dissolve in such organic solvents very easily. Electrical conductivity. In solid state, they are poor conductor of electricity, but in molten state or when dissolved in water, they conduct electricity. So we all know electrolysis, how it is done. So sugar and salt is dissolved in water, and both of them, since they are crystalline solids, once they dissolve, then they are a good conductor of electricity. Ionic reactions. Ionic compounds produce ions in the solution, which gives very fast reaction with oppositely charged ions. So sodium chloride plus silver nitrate will give you silver chloride plus sodium nitrous, nitrite. Okay. Now coming to covalent bond. Lewis-Langmuir concept. When the bond is formed between two or more atoms by mutual contribution and sharing of electrons, it is known as a covalent bond. If the combining atoms are same, the covalent molecule is known as homoatomic. If they are different, they are known as heteroatomic molecule. For example, formation of hydrogen molecule, one hydrogen has one electron, other one also has one electron. Together they are stable with two electrons. Oxygen has six electrons in the outermost shell. They share two electrons, and then they have eight electrons that are with four each and four that are shared. H2O, you know, hydrogen has only one each. You know, oxygen has six. So they share, both the hydrogen share it with oxygen, and together they have a stable structure. And then nitrogen, nitrous hydroxide will again have five, and then it will share one each with every hydrogen, so that it has three hydrogen that attached to it, so that they can get a stable structure. Lewis representation of simple molecules. The Lewis dot structure can be written through the following steps. Calculate the total number of valence electrons of the combining atoms. Each anion means addition of one electron, and each cation means removal of one electron. This gives the total number of electrons to be distributed. By knowing the chemical symbols of the combining atoms after placing shared pairs of electrons for single bond, the remaining electrons may account for either multiple bonds or as lone pairs. It is to be noted that octet of each atom should be completed. Simple enough, we've already studied that in the past. You can see how the dot structure is created, and you can understand if it's a single bond or a double bond depending on the number of dots that are there. There are some examples, you should go through them. If you have any question in these, please let me know. Now we will